Next up, we've got Peter Rowlett and maybe Alex Corner. Is Alex going to be with us today? I didn't see him in the...
So Alex should be here,
Okay.
but I'm going to speak. We thought in a sort of 6-minute thing we wouldn't have time to faff about.
Indeed. Okay, so I'll just do a quick
Alex might watch the chat. It's very hard to do both at once, right?
Yeah. So I'll do a proper introduction just for the sake of the YouTube video. So anyway, next up, teaching and assessing unseen problem solving when exams are taken online at home. Peter Rowlett and Alex Corner. So Peter, if you'd like to start, please.
Thank you. Hi. Right. So yes, we have a module. We're going to talk about the assessment for that module. I'm going to speak. Alex Corner wrote this talk with me. He's in the room, and he might answer things in the chat if you ask them. So we have a module called Game Theory in Recreational Mathematics. We've run this 3 times since 1819, taught by me and Alex with David O'Sullivan and Katie Steckles at various times. I think David might also be here, so he might pop up in the chat as well. This is not a module designed to teach a specific mathematical topic. What we're doing is using recreational mathematics, i.e. puzzles and games and whatnot, as a way of engaging students, and the learning outcomes are around communication and problem solving. With the precise topics we chose, a little bit arbitrarily, are combinatorial game theory, graph theory, combinatorics, and a bit of sort of algorithm and computation stuff. These are all topics that lend themselves quite well to puzzle-based questions or to the analysis of gameplay. This is a short talk, so I'm going to talk more about the assessment and what happened under COVID. We wrote this paper about the development of the module, so about sort of what is recreational mathematics and what can it do for undergraduate teaching, the development of the module, and so on. So please have a look at that if you like. The assessment traditionally, the first year we ran it, we have a first assignment, which is an essay, and they choose whether to write on a historical topic or an educational topic or a sort of puzzle exposition thing. There is a second assignment, which is mathematical problems, more focused around algorithms, kind of the sort of thing you'd want to give them in a coursework and not in an exam, because it's a little bit more time consuming or what have you. And then an exam. Now, we don't put an exam on a module lightly. We think about whether that's the right method. Here we thought it was the right method. So what we've done is we did a section A for 40% of the marks, which were questions using the taught techniques from sections of the module. And then we had a section B on unseen problem solving. And I quite like saying we only have the section A basically because we lost our nerve and didn't dare do the whole thing on unseen problem solving. It's that sort of thing. The unseen problem solving, we give them 4 puzzles, the likes of which they hopefully haven't seen before. And it comes with this disclaimer at the top, which is full marks for a correct solution that is very clearly communicated. And then for an incorrect or partially correct solution, marks will be awarded for clear evidence of applying a systematic problem solving approach. And we teach a sort of Polya-inspired heuristic. Here's an example of an exam question. So on this board, the king moves in the usual way for a king, up, down, or diagonally. And the question is only proceeding, if you like, how many ways are there for the king to move from bottom left to top right on this board? So that's the sort of thing we have as a question. Now, the marking for this, we mark if it's correct. We give high marks for answers that are very well explained, that show some evidence of the problem solving process, especially things like if you've got a solution, how do you know that solution was correct? How do you know that solution was complete? Could you sort of reflect back on the process that's got you to that point? And then we also mark incorrect solutions, right? Which may surprise you for an exam. And there we give high marks for clear evidence of applying a problem-solving process, for making progress, for doing sound reasoning, and for explaining what you're doing well. So that is how we do it. It is perfectly possible to, and students did, to get a first-class mark without solving the problem correctly. That is because I don't really care if you can solve this particular puzzle. The thing that I'm trying to assess is whether you can approach solving unseen problems and whether you have a sensible way of doing that. Now, whether you happen to get to a solution in the perhaps half an hour you have in this exam 30 or 40 minutes or something, that you wrestle with this problem. If you happen to get to a solution, that's grand, good for you. But that isn't really the thing that I'm assessing. And actually, what we noticed is it's a bit of a problem for students who just spot the solution instantly. They then slightly struggle to explain it in a way that shows that they've understood how to do problem solving, because that flash of insight is sometimes hard to explain. Anyway, yes, so that's what would happen under normal circumstances, right? So then COVID happened. So this, well, a bit earlier than this time last year, the university decided to put exams in the 24-hour online format, right? So students would have a start time and then until that time the following day to submit it. This raised some problems for us, and we decided not to run the exam in that format. And we've stuck to that decision this year as well when the same thing happened. The purpose of the exam is to test unseen problem-solving skills. And there is an issue with that if the students are able to communicate, if they have access to the internet, if they can start Googling around for things that might help them solve these puzzles. So that's not ideal. That's part of the reason that we made it an exam in the first place, is that we could get them in an environment where it was just them against the puzzle without any of these sort of extra resources available to them. And actually, one really significant issue that we were worried about was we don't think the students are very often going to get to a correct answer in the time available. But in 24 hours, they may well keep banging their head against the screen until they, get to a solution. And that's not necessarily good, because I don't really care if they get to a solution or not. I want to see that they're heading in the right direction in a 30 or 40-minute window, So we decided not to run the exam in the online format. The question then is, you've got this learning outcome. So how are you going to assess it? So if they aren't going to demonstrate their problem solving skills in this way, what are we going to do? So we wrote an exam replacement coursework. We took section A, because we'd already written the exam. We took section A from the exam, and we put that in the coursework with an additional emphasis on checking that your work is correct, because we thought in a coursework environment versus an exam environment, there ought to be a little bit more you ought to be able to make sure that your answers are correct in some way, either using software, using a different method, etc., etc. And we wrote a new section B. Section B said, choose a question from last year's paper or 2 years ago's paper, and write a narrative explaining or describing how someone who doesn't know how to solve this problem might attempt their solution. Okay, and you should use this opportunity to demonstrate your understanding of the steps in the problem-solving process and give mathematical notes describing what the person might attempt and what the results might be. So the idea is that they're supposed to be demonstrating their ability to do this problem-solving, but they haven't got a new problem to do it on. They're going to fictionalize somebody who doesn't know how to solve one of the puzzles from the past paper. Yeah, so that's what we came up with. There are a couple of common approaches to this. So one, the sort of less good one, I should say we gave them the answer, right? So we gave them the past paper and we gave them the answers to the past paper. So that then removes this issue of, can they happen upon a solution online? Do they pass a solution around if they find one or whatever? Don't care, because I gave them the solution. That's not a problem. What I'm interested in is the process, and do they understand how to solve a problem like this? So a bunch of students basically gave us an annotated version of the given solution, proceeding from one step to the other as though it was totally natural, without really explaining what was going on. So they would just be sort of, and next the problem solver happened to notice that this, if I do this, then this happens, and then if I do that, and it's just like, well, you're just talking me through a piece of algebra or whatever. You're not sort of telling me anything that's not already in the solution. You're just annotating it a bit. The much better versions of this used the solution that we'd given, and sometimes in quite a contrived and sort of performative way, to point out the bits of problem solving advice and how they would move the solution along. So they would write something like, next the problem solver tries some smaller cases of this problem, and in doing so they notice a pattern, and they try and extend that pattern to the size of board that's been given in this question, or whatever it is, so that they're sort of going through this process of saying, and now I'm going to do the next thing in the problem solving process. But that's sort of what they do in the exam as well. And that's kind of what we want them to do, because we want them to show us that they've learned how to do this skill that we're trying to assess, I suppose. Anyway, it seemed to differentiate students along the lines of the learning outcome. So a couple of questions that emerged then from this as we were preparing this talk. I mean, one is, do we need an exam, right? So we've run the module 3 times. Once we did it with an exam, twice we did it without an exam. We don't seem to have a problem giving the students grades. It's very hard to answer the question of whether students are, is performing problem solving the same as kind of fictionalized narrative demonstrating problem solving. It's very hard to say whether the marks would be the same if you did both to the same group of students, because we don't have that available to us. The other thing that occurred to us as we were writing these slides is this is elaborating a solution through the lens of problem solving heuristics, but you could do it to in other lenses if you like. You could ask for, how does using MATLAB help you solve this modeling problem? Or even how does, playing around with, scratch work or whatever help you with the process of proving this theorem or whatever. I could imagine other cases in which, the skill that you want them to demonstrate, if they can articulate what that would be, even if they can't actually demonstrate it in this particular circumstance, might be a suitable way of doing coursework for some of these topics. Anyway, I have a reference, which is our paper, and thank you very much. And I think back to Kevin.
Okay, yes, thank you very much. That's quite a novel solution there to the exams, to give them the questions and the answers.
Sure.
So I wonder if there's any questions for either of our past 2 speakers. There are no open questions at the moment, so maybe because we're only slightly behind at the moment by maybe a couple of minutes, so we're doing quite well for time. Maybe I could ask a question. Did you actually try this out on them beforehand? Did you give them practice? Because you said that some of them didn't. They just kind of went through, just putting a narrative to what you'd already given them. I mean, what happened there? I mean, did you give them a practice beforehand, or? I mean,
we didn't. No. I mean, we gave them we talked to them about what they might be expected to do, but no, we didn't give them a practice beforehand.
Right, because it might be interesting to see that, to try and prevent this kind of. They're not quite sure what they do because this is entirely novel. I mean, I think I might be a bit worried about, what do I do in order to.
It's really hard. The other thing we considered is giving them an exemplar, but then they'll just copy, mimic the exemplar, and that's not necessarily useful either. You sort of want to see what they're going to do for themselves, don't you? It is hard because you're not asking them to do the thing. I mean, this is what Tony's put in the chat. You're not asking them to solve problems, but in some ways, how can you with any sort of, I can't give you an unseen problem that you've never come across before and know for sure that you're not, using a piece of software to help you solve it or looking it up online or something like that. It's very hard to do that sort of thing if I can't be sure that you've actually done it. Whereas this is kind of, well, and of course that happens with coursework all the time, but here you're making very explicit this thing of, well, I'm not looking at whether you can solve this. I'm not asking you to sort of pretend that you've solved this problem. I'm asking you to talk me through it. Of course, in the talk content, we had done quite a few times through the year, we'd gone through solving a problem as a class. We did our lectures. We didn't do the recorded video thing. We did a Zoom room with breakout rooms, and we so we put students into small groups and they worked through things they didn't really know how to solve, and we talked about how the maybe drawing a diagram will help you get some insight into this problem, or maybe all these different things that you get from Polya. So they had some practice with it in that sense, and kind of all year I'd been saying this thing that I'm interested in whether you can solve problems, not whether you happen to be able to solve this particular problem.
Right. Okay. I was going to suggest, has anyone got any questions for Mark? We do have a problem with Q&As for panelists when they want to ask questions. They can't use the Q&A, I don't believe. So, but Vesna, who's one of the panelists, says basically asking, what do the externals think of this? I think that's what her question is.
So we haven't had our exam board for this year is in a week or two, but last year the external was very happy with us. Yeah.
Oh, for last year. But
for last year, because we did it last year. Yeah. Right, we haven't had the panel for the exam board for this year.
Okay.
Yeah.
So I think we've got about a minute left. So that There is a question here. It says, Peter, do you not lose some nuances by eliminating the possibility of giving a wrong solution?
I'd say, first of all, that we didn't eliminate the possibility of giving a wrong solution. We had some quite entertaining ones where, like, how did you get it wrong? We told you the answer. But yes, I mean, potentially we didn't get that sort of banging your head against the wall because you can't get there, but how do you deal with that? That whole, the aspect of problem solving that is being stuck, and how do you cope with that? We didn't get any of that. You know, it's very hard to simulate everything, isn't it? Of course, you don't get that with every student anyway, because some will just see it. I set a problem the first year we did this, and you know, a quarter of the students just saw it instantly and then wrote a pretty poor answer because they just told us, I've spotted this is the solution. And then that was it. And you think, well, all right, maybe you should have tried a different question, because the point was not to solve the particular problem.
Right. Okay. Well, I'd just like to give another quick round of applause there, because I think we should take a break.